Hi, my name is Shakil Jamal, and in this particular session, I'm going to demonstrate a very interesting, highly used, highly important topic in the phase of building a data analytics project, a machine learning project, a deep learning project. So, what is that we are talking about? We are talking about a terminology highly used in the context of data pre-processing, feature engineering, and whatnot. We are talking about exploratory data analysis. Let us begin this particular topic by looking at some of its features and why is it important in the projects of data analysis and machine learning. First of all, exploratory data analysis, as I will mention, is a combination of two things. One is investigation. We are going to investigate the data. How do we investigate the data? It is something which is of extraordinary importance to us, especially in the data science industry, is that when people come to us with some sort of data element, they have some kind of questions in their mind, but they generally do not tell you. They will present to you the data and say, I do not know what questions to ask, but you do analysis. They consider people who are in the data domain to be the magician of data. So you have to produce what? Magic. How could you produce magic? It is the first time that you are getting the data. You do not know about this data before, but you have to analyze it and you have to produce some insights from it. That means it is the data that you are going to get and no question, but you have to produce answer. It is like writing an examination without a question paper. So you are only presented with some kind of data, some kind of data. This data could be as messy as it gets. It could contain multiple problematic portions. What I call it is like a stomach. This is my poor drawing of a stomach. In stomach, I have eaten a chapati. I might have eaten something, solid, something liquid. All of it is present. And from here onwards, I have to examine it via an X-ray machine kind of a stuff and need to demonstrate exactly what I have eaten. That means I have to segregate out chapati, rice, and all the food elements that have been eaten. That means that from the raw data, I am going to get some clean data. This process of converting the raw data into clean data for our further analysis is called exploratory data analysis. And this process of segregating out things, finding some value from it, is the investigation phase that I mentioned. So you are the magician of the data and you have to do some investigation in order to produce it. So comes the question, what is EDA and how do you do it? So there are certain steps to this arts of science. There are certain steps through which we do it. The first such step is called data collection. Data collection as a step could be named in multiple contexts. Sometimes data collection is also named data gathering. In some fancy terms, it is also called as data ingestion. Multiple phases. From where do you get the data? Most of the times, this data sits within your organization. Now, you may be a part of an HR group. So your HR data is your primary data. You might be in a fintech company in which financial reports, balance sheets is your go-to data. But sometimes what happens is that it is not enough for our analysis. You require something more than that. In that case, we require something to be captured outside of our organization. We will look how do you do it. After you collect the data, the second step is called as data cleaning step. I'm sorry for the whiteboard. We will produce a better slide. The data cleaning, as it says, is one of the most integral part in any data analysis project. It is also the most time-taking process because we do not exactly know what kind of errors, what kind of problems does our data have, and how to clean them up. So there is a clear sense of understanding by the help of which we get some real data. After we have done this particular collection and cleaning, our data is pre-processed enough for initial levels of understanding. This initial level of understanding, which we for ourselves do, because we are looking at the data for the first time, this process is generally called as initial analysis, divided into further two types of analysis. The first one is called as univariate analysis. Univariate simply means single variable analysis, and something called as bivariate analysis. Univariate means single variable. For example, if there is a student's database, so the marks of maybe one single column. So if we were to analyze this particular column for say average, for highest, for lowest marks, or we want to have some understanding about the range function, we are doing all the analysis on a single variable. This is called univariate analysis. Bivariate analysis, just opposite to it, is something in which we draw a two-dimensional graph. On x and y axis, different components are present. A bivariate analysis generally is an analysis by the help of which we draw some kind of correlations. The correlation gives us understanding how the data will fare. If some increase on x-axis happen, will it affect on the y as well? Example, if say I increase the discount on any product, what is our general presumption? We will presume that our sales will increase. This presumption, whether it's true or not, we will test it. And this presumption and its testing is done after this particular phase, and it is also called as hypothesis. Hypothesis is nothing but whatever kind of assumptions we are making. These assumptions should be backed up, should be proved on the context to prove their point. So after we have got some data collected, we do some cleansing, we do some basic analysis. This analysis again requires some visualizers. For example, in univariate analysis, we generally use some graphs like histograms to plot a single variable. For bivariate analysis, a line graph, a scatter plot may be used. After which we get some hypothesis, and there are some statistical methodology to formulate this hypothesis and test this hypothesis. There are multiple tests like t-test, z-test, ANOVA test, chi-square test, multiple. After we have done this testing and we are through that our analysis is correct, then this particular data is finally good enough to do some feature selection and dimensionality reduction for the final phases of our models to be loaded back in machine learning models. For a machine learning model to function, We have to make sure that our data is cleansed enough, we are correctly guided towards the dimension, and all this process is done through the process of EDA. Let us look at all of that one by one. If we talk basically about the data sourcing, how do we source the data? As I mentioned, that data could be sourced within organization, and that kind of a sourcing is generally called as private data. The private data is within organization data. In here, this data could be represented to you maybe in structured format, like a databases file, maybe in a semi-structured manner, maybe like a JSON file, or completely unstructured format. Maybe you are trying to find out some value from an email. So there could be multiple ways from which you get the private data. But as I mentioned, sometimes it is not enough. In that condition, we have to take some help of public data. What is public data? This is the data that is available for the common folks. There are multiple websites which provide some data sets. Let me show you a few examples. For example, here, if I go back to say here only, if I take an example here, and let us say that we want to analyze what are the different data elements we can get. We can get it directly. The most important is a Kaggle website. Kaggle provides tons of data sets, ready to use, free to use, for different kind of models altogether. It is the primary source of learning. From here, you can get multiple competitions, multiple data sets, and it should be used regularly. After Kaggle, there are multiple other data sets that you should also try. There is something called as UCI machine learning repository. UCI machine learning repository is another such, uh, you know, publicly available data sets which you could directly load, which you could directly use for multiple domains. Then for our purpose, it is better to use some kind of important data sets, specifically when you are dealing for say e-commerce business or businesses which are concerned with the government for their funding. Then data.gov.in, which is open data initiatives from the government of India, is a fantastic platform by the help of which you could get multiple data sets. These data sets again can come in multiple formats. These formats may be API, maybe CSV files, database file, Excel sheets. There are multiple ways by the help of which you could get in multiple domains. There are about 6,11,000 resources, a lot of them. But what happens generally after you get all of these, you know, websites? From these websites, you may get some visualization, some work. What generally happens is that these are not specifically meant for your project and require you to do some work on your own. In here come the process of scrapping of data. All the data that is available may not be enough for you. In that case, you may need to take the data all together within yourself. This particular process of capturing the data from a website or from a mobile phone or from any social media site as such is called web scraping and is highly used in competitive markets. It is something which requires some kind of permission, and in here we get some publicly available data sets. There are some availability of data sets, and we can then do some scrapping. Both are possible. I'm very sorry for my handwriting. My stylus is unable to give the proper configuration. Now, let us deal with a question to see whether we are understanding the public and private kind of data altogether or not. Let us see one more time. Commodity prices. What are commodity prices? For prices like rice, dal, multiple things that government of India produces. These prices needs to be known by common people. So it is a public data. Then medical data, which you have, and your date, this data is very personal to you, only you and your doctor knows. This is completely private. Then user input, what you are inputting. Now this is an ambiguous question. If I am, say, putting my input on a bank website, it should be private. But if I am inputting the data on a social media site, it should be explicitly public. So here comes the catch of user permission. It is private in nature till permission or consent is given to make it public. Similar is the case for population of a place for which we have census. Census data is again a great source for public data. So it is again what? Public in nature. Contact information, private till I make it public. Website traffic, for my website, it should be private till I sign for something like Google Data Analytics, maybe Google Ads, then it becomes public. Stock market prices should be public for everyone to see. Census data again is something which is public. So these are the various ways by the help of which we can understand when and where what kind of data is required. Let us take an example altogether before we jump in to any conclusion. Let us take this particular one. Okay. In here, what we have got? We have got some values. This is a CSV file. As you could see, this CSV file has some kind of common elements and some kind of special elements. How can we eliminate out these and can work with the other? Understand very well that these elements are here in the format of a CSV file. If you can work whether this CSV file, why is it loaded in Excel sheet? Well, because it has got some structure to it. It is a structured data which could be represented in rows and columns. If better, let me take the actual values that are present here. Let me go to my downloads and see for it how this CSV file present. If I directly open that up, say in a notepad, maybe a wordpad will also do. Okay, it is unable to open because it is being used someplace else. Let us make a copy of it and then open. Because it is a big file, it might take time, but now you see. How is it represented? It is represented like a lot of commas. Look at the data. Banking, marketing, comma, 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 comma. This is the first line. Then customer ID and age, comma, comma, some values. Finally, in here, what we can see actual values 1, comma 58, comma 1000. Some kind of comma separated value is there. It has got a structure, but not a model. That's why we call CSV data to be structured data. Once we model this data for some existence, we are talking about a database file, especially in RDBMS setting. Let us look back in our Excel file. So the sourcing of data of a CSV file can be done using multiple tools. We can load it using Excel. We can load it using a BI tool like Power BI or say Tableau. or we can use Python to do the same thing using its data frame structure of pandas. Let us see first of all in Excel. Once we have opened this Excel file, look at the data. If you could see that those comma files are now represented as rows and columns. This is a row and these are the columns. What is the total size of it? It is better to go to the last line. So if I simply go to the last pages, I could understand it has got about 45,214 rows and the number of columns seems to be about 20. So 20 columns and or 19 columns to be precise and 45,214 rows. Let us come back to our home. You see here only that there are some kind of mistaken identity. Like banking marketing is open and all other columns are empty. Also, we see some of these columns that are present here as to be empty. All of them are not filled properly. That means there is some kind of problem with this data. What it is and how to solve, that is the process that we are going to take in the second step, that is called data cleansing. Let us come back to the cleansing phases. After we have sourced the data, we can get the data back. Okay, let me also show how to take the data in our notebook, in our Python setting. I have opened a Jupyter notebook. For loading these kind of data, I require a special kind of a data structure for a CSV file. This is presented to me by a different kind of library, and that is called as pandas. So first of all, let me put it in the coder as EDA. Now this is a heading tab. After I have done the heading, let me start with the first step, and that is called data gathering. How do I get this data? If it is in the same folder, it is easy for me to work with. Let me make it a subheading. For that, I simply need to do two things. Simply press double hash kind of a symbol and select it to be a markdown. By a markdown, it will not execute the code, but it will take it as a theory. In the data gathering process, let me catch the data using pandas library. Pandas is a library by the help of which I can do this data frame object. So I simply need to import pandas, and then there is an optional statement which is called as alias function as PD. It is optional but used so that we can easily refer to pandas as PD. Let me execute that. For the first time when I'm executing it, it will take some time because it will catch a kernel. Kernel is something which is built on top of an operating system and uses the clusters of CPU and GPU together so that our programming can be done faster. That's why we are doing it in a browser like Google Chrome. After we have taken this pandas, there is a very simple way to take the data or gather the data. It is called pd dot read CSV file. Read CSV is a function by the help of which I can simply pass which particular data set I want to take. So the name of this particular data set which we have opened here is called what? It is better that you use this in the same folder so that you could work easily. So its name is this bank marketing update. Otherwise, you could give always its address by looking at the address column. So let us load this data. Read CSV file. Okay. And this is a CSV file. Now this will be able to read it, but we want to store it in some frame. So we generally have this data frame object. It is again a name. I can name it anything. I could name it data. I could name it data frame, whatever I want to do. Let me load it up. Now it was able to load it up, but there is some kind of a warning that it is giving. I could always remove this warning by importing the warning as a module as well. But let us see what kind of a warning it is giving. It is giving us a warning of data type. What kind of problem and what kind of a warning is it giving? How to see that? There is simple kind of methodology that we use as PD, because in the pandas library, and we have loaded it into a data frame called as data. I'll simply press data dot a head function. Head is a function by the help of which I can see some values. This is like investigation. I am looking at the data, glancing at the data. Let us see. Oh, that's the problem, which we saw in Excel as well, that it is able only to take in the first row bank marketing and then nothing else. It seems to me that banking marketing is the header or is the title of the page, but it is not good enough for my analysis. My analysis only starts from here, from customer ID. What is the name of the column and what amount of data I want to have. So I can understand that this column is unnecessary. This complete row is unnecessary. I need to remove that up. Here comes the catch of data cleansing. After we are done with gathering the data, maybe in Excel, now in Python, I can do the same in Power BI. I should move ahead and do some kind of changes to this data so that our analysis can work. And here come the cleansing of the data. It is a lot of time, very time taking, very slow in nature. I have got some kind of an understanding how I do the thing. Let me share it with you. First of all, I look at the problems in rows or columns. If there are some problems in rows and columns altogether, what I call as structural problems, first of all, let us look at that. This is the first thing that I do. After I have taken the structural look, I generally look for null values. That means those values which are not present. Once I was doing an analysis on a project. It was a project about 10,000 rows and all the numbers were there. But whenever we were trying to add those numbers, trying to do the maximum minimum, it was throwing an error to us. And at last we found out that out of all the values, at one point of time, a student was absent. So the teacher marked him XX. Now the XX is a character. It is not a number. So this kind of values sometimes create a nuisance for us. Sometimes what happens is that people simply leave it blank. What that blank means, is it an error or is it left blank purposefully? That needs to be done. So these null values, and to handle these null values, there are multiple techniques. Then after looking at the null values, I look again at this inconsistent data. The inconsistency of the data is again the same thing. XX value, some character value, some dollar symbol is there. Some kind of problem here and there might happen. It also requires some kind of checking of the data by looking at various data types, what kind of analysis is to be done, whether it is a numerical category or a categorical type of variable of non-numerical type. After looking at the inconsistent data, we generally go for the fourth phase, and that is looking at outliers. Outliers are something which are completely out of context. That means, say the values are between 5 to 100, but some value is outside of it. Means in millions, maybe due to a typing error, or maybe it is simply showing a value that should not exist. Maybe all the values are in positive, but one value is in negative. Example, car ka mileage. I am talking about car's mileage. It should be between 0 to, means it should not be less than 5 kilometer per hour per liter. and it should not be more than say 40-50 kilometer per liter. But somebody is saying that per kilometer it is 500 kilometer per liter. So there is a chance that this is a wrong entry of data. So outliers are one of the important things. Then we look at some noisy data. By noisy data, I mean anything that is extra, anything that is not required and is present. Handling all of these requires spatial techniques. Like for outliers, we have box plots. For noisy data, we have something called as scaling options. For null values, we have solving options, and that is called as data imputation. Let us look at a practical example in our Excel and Pandas both to understand how do we do the cleaning process. Why do we do the cleaning process is again a question. The use of data cleaning is to remove the noisy data, inconsistent data, transformation to correct the wrong data. Let us look back at our Excel example. Here, as I mentioned, that the first thing that I look at is structure. As you see that this row is completely empty, it is not required. So it is better to remove this row altogether. How do you remove? Simply select this row and press Control minus. It will not just remove the contents but also the structure. Similarly, this row. Now what this row is? This row is saying customer ID and age, and here is our customer ID. It is better to select all of them like this and press double E like this. So it is better to look at the data. So it is customer ID and age, and it is explaining to me what these columns are. Customer salary and balance, and explaining to me what these columns are. Customer, okay. So it seems to me that this particular row is an explanatory row. It is explaining to me what the other columns are doing. Again, for our analysis, this is unnecessary. These are called summary rows. First one was a title row. This is a summary row. We should remove that up. And for our understanding, rather than having it here, we should have it someplace else. And here comes our dictionary. Data dictionary is generally developed in any machine learning or a data analytics project so that we can understand what every column means. So customer ID is there to represent the column is about the ID of the customer contacted. Similarly, for all the columns, what it means, we should create a separate file in which all of that should be happening. That is called data dictionary. Coming back. Now let us look at the data. Now our structure is okay. The second thing that I mentioned is to look at blank values, null values. How do I do that? I generally take all of that data and convert it into a table so that it is better to look at the data. How do that? Simply click on any particular cell and just press Control A. It will select automatically, and then press Control T, T for Taj Mahal. It will ask me to make a table out of it with some headers. Let me press OK. It will automatically convert my entire data set into tables. Let me again redraw all the values. Now it is better. Now let me look at null values. In customer ID, if I click on this drop down menu, I can see all different kind of values altogether, but I do not see any null values or blank values. That means that this column is not having null values. Just next to it is age column. What does age shows? Age shows multiple type. The minimum is 18 years. What is the maximum age? The maximum age is 95 followed by some blanks. This blank shows that this data set contain null values. This is problematic. Let me unselect all of them and only select the blank values. By looking at the blank values, I will be able to understand how many blank values are there. Let me only select this particular column, and I could see that it is about, okay, if I simply select it like this also, it would be better. So it is about uh, it is about 100 plus values, if I'm not wrong. I think my sharing screen. So it shows that it is about 100 different values that are empty. There are multiple other ways to do that by looking at the duplicate values, etc. But for our purpose, let us see that these are the blank values. How to handle these blank values? This is a great question. For that, what I generally do is to look at all the variables first and look at all the variables with numbers. So age seems to me that it is a number variable. Salary seems to be a number variable. Balance is a numeric variable. But marital status, not. Job and education, not. Targeted, not. Default, not. Loan, not. Now, day, month, or duration could be said as, but it is again not a factor variable. It is a time variable. Similarly, for campaign, it is kind of value which is highly changing in nature. So we can't do much analysis with that. In the process of ETA, for treating the null values, the best way is to impute some values. What should I fill here? To fill these blank values, I can't leave it empty. Either I could remove the column altogether, but it is not a good idea. Rather than that, let me create a summary table. This kind of a summary table is also called as descriptive statistics. What I want to do, I want to calculate a few values by the help of which I can demand and demonstrate. So let me look at the mean value, median value, mode value, which are central tendencies. Then also let me look at the range. The range is basically maximum minus minimum. So instead of maximum, let me start with minimum value first. Then look at 25 percentile. At 25 percentile, what value is? That is also called as first quadrant. 50%, which is also the median value. So 50% value. Let us also look at 75% value, third quadrant, and 100%, which is the maximum value. Let us look at all of that data for all the numerical variables. What are the numerical variables that we have got here? We have got age, salary, and balance, right? Let us unselect it first. Let us take age, salary, and balance, and let me put it for the descriptive statistics here. Okay. How do we calculate the mean value? Mean value is simply the average value, right? Let me put it here so that it is more visible. So I can simply play is equal to average, and in the average function, let me mention this particular table altogether. And let me take this up so that I could use it for future purpose as well. Let me print enter. So I see the average value to be 40.9 with some blanks. Let us also look at the median value is equal to median, and let me again paste the same set of values. So I see 39, and the mode, for the mode, let me put again the same values. Sorry. Mode value, that is the most frequent value, is 32. So most of the people are of 32 age. Range. What is the range? Range is simply maximum minus minimum. Let us first calculate minimum value. Minimum is equal to minimum of the same range that we are calculating for age. So minimum is 18 that we saw. How do we calculate maximum? Similarly is equal to max. And in the max, let me again give the same range. I get 95. So I am correct. How to calculate this 25, 50, and 75%? First of all, range. Range is equal to maximum minus minimum. So it is 77. Okay. 25 percentile. For percentile value, I generally have quartile symbols. So with quartile, sorry, with quartile, I can again give the same value. And then I have to give what quartile am I looking at? I want to look at the data for the first quartile. So the first quartile means 25 percentile. Let me execute. So the first quartile is 33. Similarly, let me put for 50 percentile is equal to quartile. Again, the same with 2. So it is like, oh, sorry, delete that up. Let us simply take the same values here. It would be better for us to solve in that particular way. I'm sorry, with my pen tab is happening. So it shows 39. Similarly here. Now we see that it has done for the age. Let me simply copy that up for entire set so that we can do the same work easily here. Sorry, my mouse doesn't seem to work properly. Just give me 1 minute. While it is happening, let us try to look back at the data. What our data was. Our data in our Python, the same thing we can do. Now, what I did for the first time, I simply removed these two columns. I can do the same thing here by just removing that particular bit of, rather than loading the entire data set, let me copy this up and load the data set in this way that the first two rows, let me skip these two rows, the first two rows, which are showing some kind of elements, let me skip them altogether. How to do that? Simply write here skip rows equals to 2, and it would simply skip the rows. Now if I look at data dot head function, it will display the rows with our columns. So the first thing that we did, removal of rows, is successful. Now as far as looking at the data is concerned, there are multiple ways through which we can do the same thing. The easiest way to look at the data is not through head function. It is rather to do it with a sample. Sample randomly select some value. So for sample, if I execute, it has randomly selected this particular column, 14,238. But that is not, again, very nice thing to see. So rather than doing that, what I do is to look at the various structure by putting some kind of arguments. So I put 10, so it has given me 10 values. Now I could look at the data in a better way and could understand better amount of things. It is also a good idea to find the overall structure, overall work, how variables are done. So I could simply do it by shape function or shape keyword. It will show me the number of columns as 9, total number of rows as 45,211. That is my size. If I also want to look at the information of the entire set, how many of them are categorical, how many of them are numerical, what kind of analysis can I do? I could do that here. So here it has put for me all the columns, and in here, if I get it either to the integer type or float type, it simply means that I have got the data as numerical. All the types which are of object nature, these are called as types of categorical variable, which are not required for us. Maybe not required for direct computation. We can do some kind of changes to categorical variable for analysis, but correlation generally can't happen with categorical variable. Working with categorical variable requires us to convert them through some mechanism to numerical variable, and this kind of conversion is called as encoding. Before going on that, let us look at the same thing that we were doing there in Excel by looking at basic descriptive statistics. Here it is very simple. It automatically takes the numerical variable and converts all the functions that we were doing. So if we do by the help of describe function, it simply goes for our numerical variables. It has taken all the numerical variables, gives us the count, total values, mean value, standard deviation, minimum, maximum, and all the percentile. Let us look, हमारा Excel सही हुआ या नहीं? So we see yes in Excel, the same thing has happened clearly. Let me just increase it a bit so that it is better to work with. Yeah, now it was able to do that. Let it be loaded, because again it is a big file, and for Excel to handle these files becomes a bit tedious. So let it sort it out first. Once we have sorted out this particular process, why is it required? As I mentioned that there were some null values there. We can handle these null values. How? Just by understanding which kind of value requires to be imputed or put in that particular place. Even if I look at the age data here, you look, the age data starts with a mean value or average value of 40.9, which is like 41. So either I could put the mean value there as 41, or I could put the most used value, that is 32. But these are not really good terms to put. Why? Because in the range function, I see that it starts with 18 and goes up to 95 with the median value to be 39. This shows that it is much more left side oriented. 18 minus 39 is how much? 21. While 39 to 95, the difference is about 56. So the difference between the lower elements and the higher elements is high. We say the data is skewed towards the left side. Whenever there the data is skewed, that means the distribution is not proper. Here also we could see by the standard deviation. The standard deviation here for our age column was about 10.6 with minimum of 18 and maximum of 95. This shows that the data is skewed towards the left side and is generally not a good principle to fill the mean or the mode value. For skewed data, we should always go with the median value. The median value or the 50 percentile value is 39. That should be the value we are going to fill. How to impute that in Excel? Let us see. Again, because it is quite heavy, let us come back and see all the values that are blank in nature. Now, in all the blanks, what we are going to fill? We are simply going to fill the median value. Median value was what? Median value was what? 39. So we simply will fill 39 altogether here, and it will give us some kind of understanding for the null values. As you could see that Excel is getting loaded once again. I think we should stop some of the values. Let us stop our Jupyter notebook so that it can have better resources. So in here, let me fill another important thing I want you to understand. Look at the job education. It shows that there are two values that have been assigned together. This kind of assignment, when more than one value is available and is put together, is generally not a good practice once again. So here let me put 39 or is equal to median value, whatever I want to put, equals, go into this sheet and this particular value, let me put enter. Oops. Let me put simply is equal to 39 and let me just drag and drop all together to the last. It will fill all the values. Here in what I could see is that job education, there is some kind of a problem here. For this kind of a problem and to handle this problem, now all my data in age is at least filled. Let me go back, select all, and I could see here in the select all, there are no blanks. That means our data is now cleaned for null values as far as age is concerned. Same kind of thing we can do with salary and balance. But let me focus on another type, that is inconsistency of data. In databases, we call if there are comma separated values present inside of one single column, that means that this data is inconsistent. This is not properly formatted. Handling this data is necessary because again it will create for us some kind of nuisance, some kind of problem. How to handle that? The best way to handle this is to separate out or split out the columns. We can simply split it out by looking at the data tab and working with it. Let me close my server altogether here and let us focus back. It is generally a good practice that if the data is more than 10,000 in the size, do not go with Excel. Go with Python or another BI tool because otherwise this kind of things happen. Now, if I want to simply segregate out because it is not looking nice to me, I simply can go to the data tab here, and in here I could find this text to columns option. Text to columns give me some kind of answering by what to do. I simply want to delimit it or change it into two columns. Let me put next. It is not tabular formatting. It is rather a comma that is separating it. As soon as I click on it, look, it was able to understand it together. Let me put next. Do I want to replace it? The answer is yes. Now you see, it was able to put into two different formats, job education and targeted. In the targeted column, okay, I have put it back again. It is not a nice thing to do. It is rather a good idea to put it someplace else and then to fill it back. So rather to do that, let us put text to column again, get into the next, put the comma in. Instead of F2, Let me put it in Z2 or something. Let me put it here. Now you see two different columns have been made, and uh, that particular data has been separated out, and these two new columns have been made. If these two new columns have been made, this simply suggests that now our data is unique in nature. In the case of databases, this is called first normal form, that for every cell, singular data should be there. Similarly, we can do that for here month and multiple cases. Let us come back. Again, it is taking a lot of time. We could have also shown some basic analysis like univariate and bivariate, but I think that the data is getting loaded in a very hefty manner. Yeah, it is done. I only want to do two things. Let us not get into that. So now job education could be deleted altogether, and two different columns have been created. In here, where I have created this descriptive statistics, right? And in here, where I have created this descriptive statistics or summary data, let me also put in some kind of graphs to look at univariate bivariate, because it is generally a good practice to do. Let us look at this univariate by a single variable. For example, this age. Let me select all of it, go to insert tab and insert any particular chart. Let us say a column chart. Yeah, it will do. Now you see that it has automatically created a chart for us. Yes, for us, it has automatically created a chart showing the range and functions. But it is not able to give the real values. So better to do what is to select this up and uh, you know go to this particular plus icon and select for all the values that I want to have. Select it first, and it is called a switch row column option. Now by that I could also go with multiple accesses, multiple columns, and you could see that it is unable to show us the another important aspect that I wanted to have. For that I could have chart filters here, right? And other than filtering, I could also have something called as names. Okay, let it be. Yeah, select data option. In the select data option, I can simply put, rather than this horizontal axis, let me edit it and put some other value. So this should be the mean median value, which could represent some kind of an analysis of how age functions are working. Now you look, that minimum amount of data that we were having here was what? Let me put it in a bit bold way. Or it is better to take this away and put it in a new chart altogether, which could be presented data. Now you see that the minimum value was about 18 years of age and the maximum was 95. It is able to show through this particular single variable analysis how the data could be put. Similarly, for two values, I could simply compare salary and balance. If I compare salary and balance altogether, it is better to show it either in the form of a line graph or some chart graph, or even some cases of pie charts. Let me show basic analysis by not hierarchy chart, maybe a line chart will do. Yeah, that could also show. Yeah, this seems to be a right version, right? Let me control X, put it again back here. In here, I could simply again select this particular chart, go to the chart design format, select the data, and look for salary and balance. Different for salary and balance, it is showing a percentage. I could again, select the data and change it altogether to different kind of accesses that I want. Uh, Let me edit it up. And for labeling, let me again go back here and let me again select these labels so that I can have a better analysis of the data altogether. Just 1 minute. Yeah. Now you see that the data that we have got, and now you could add some title value, comparison between salary versus the balance, a balance of loan, salary versus balance, multiple ways. After this bivariate analysis is done, some univariate and bivariate analysis is done, we are good to understand which of these columns are necessary for us, which of these are not, and then we can switch back to what is required, what is not required. What is required and what is not required is something that comes back to us. So that is my basic kind of a presentation. I have tried to give an overview of how exploratory data analysis work. It is just uh, tip of iceberg. It is a in-depth topic, lot of statistical methods, lot of methods of cleaning of data, getting multiple type of data. If I were to get the data from Excel sheet, different type. If I were to get the data from databases by connecting ODBC drivers, if I were to get the data from, say, scrapping of the data from web pages, HTML based elements, if the data was needed to be taken from, say, some server, so maybe a CRM, customer relationship softwares, some HR softwares like Darwinbox, some fintech softwares, or data from cloud. These are the essential components that one needs to understand so that they can work not just with CSV sample data, but with multiple data formats. Sometimes we need also to make our own data warehouse by putting in all together data from different sources and creating it via creating a pipeline, and finally being able to give some kind of analysis of what is required. This is the magic with the data that I was talking about. I hope my presentation finds you well, and some kind of hicks here and there would be omitted in the next step. Thank you very much. Thank you very much. Bye bye.